Good morning and afternoon to everyone. Thank you for joining Kevin, Maria, and I as we discuss our next topic in the series of webinars, LIDAR applications for power substations. My name is Dustin Spillman. I'm a senior project manager here in the survey group based out of Charlotte, North Carolina. Joining me is Miss Maria Thorpe, who will be the moderator, and Mr. Kevin Hanna, manager of Terrestrial LIDAR Services. Together with the team, we have successfully completed over 400 substation surveys utilizing LIDAR technology. Surveying challenges that we come across when performing work for a substation. For this work, it offers a slew of challenges, but we've narrowed it down to some of the 5 biggest ones that we usually come across. The first one is working around energized equipment. It is the most important thing to consider. It is recommended to avoid contact at 50 volts or more. As you might be aware, substations range anywhere from 69 kilovolts to even up to 500 kilovolts and beyond. Another thing to consider is how dense or developed a substation is. As you can see in the picture, this station has a lot of equipment, a lot of features that offer many challenges when surveying. Another thing to consider is your controlled access. This will prevent you from accessing certain areas or even being allowed to enter the substation. Utility companies may require special training, escorts, and other controls to ensure the integrity of their facilities isn't compromised while you are doing work at the substation. When you're inside the substation, your time is limited. You want to be able to get in, get all the data and everything that you need to meet your scope of the project, and then get out. And this will reduce, the impact to the utility and your workers. Lastly, the substations, they vary in size. Some are as simple as a 30-foot by 30-foot square, while others, like the image to the left, it covers large acreages and large tracts of land. So first, we're going to look at sort of a conventional survey approach and sort of what those challenges that I just mentioned, how conventional survey almost adds to those challenges. When considering working around energized equipment, to collect the data, equipment requires like lockout, tagout procedures, which causes interruption to the utility facility. And this has to be performed by qualified electrical workers, adding to the personnel that's needed for the project and inside the substation. At times, the surveyor, he's not a qualified electrical worker, and the electrical qualified worker, he's not a surveyor. So there's a lot of opportunities for miscommunication and issues to arise when you have to deal with these type of issues. Another thing to consider when conventional surveying is the tight quarters of the substation. The crew or worker may not be able to physically access some areas. Another thing to consider when using total stations and other conventional methods, you have to be physically inside of that substation site. Once again, exposing the team and project team to those facilities and something you just don't want, try to want to mitigate. Finally, conventional survey, you're typically limited to one method to collect your data with that total station, GPS, your conventional survey methods. Kevin, would you like to add anything as far as conventional?
No, I think the only thing I would add is that the safety factor here, given that these sites are energized, there's high voltage running through all of the equipment, so LIDAR is an excellent non-tactile way to gather this information without having something physically near this energized equipment.
Yeah, and that brings us to our main topic of our conversation today, is, how LIDAR Solutions can help reduce and even eliminate many of the challenges of the substation survey. So again, looking at your energized equipment, LIDAR enables you to collect survey grade data with no interruptions or the need to have qualified workers perform those lockout tagout on the substation equipment. The main thing is it keeps everyone safe at the site. Additionally, LIDAR allows you to collect data that you might not otherwise have access to. You essentially, if you can see it, you can survey it. Again, everyone is safe. Number 3, with LIDAR, you have the range to collect from a distance. Once again, eliminating the need to get close to the equipment. When considering the size of the substation, it would eliminate the need to be inside the substation. And as we look at the hierarchy of controls, elimination is the top of that, control pyramid and the most effective safety control measure to keep everybody safe. And with the speed of LIDAR, it greatly reduces the time inside the substation. Instead of collecting individual points at a single moment, LIDAR is collecting hundreds of thousands of points per second, essentially creating a 3D image of that substation and those existing features. Anything that you can see, we can survey. When considering the size of the substation, there is an appropriate LIDAR application, no matter how big, small, developed, or undeveloped that substation is. So we're going to touch on, the 3 main components of LIDAR or method collections of LIDAR. Your first is static or terrestrial LIDAR scanning. Here, the equipment is set up on a tripod. Similar to conventional survey, you can collect up to 1 million points per second. Ranges vary based on the equipment used, but typically there's an effective range about 250 foot. With some of the newer models and newer equipment, drastically increasing that distance. Next is the mobile LIDAR solution. These are units that are mounted to a truck or vehicle where you can drive at speed collecting survey data. Typically, these are used on your highway projects, but they also have their applications for substations. Last is a LIDAR unit that can be mounted to a UAV or drone. These are flown at heights no greater than 400 foot above ground line. And these are, applicable to, many types of surveys and projects. And, we're going to dive in and take a closer look at all 3. So the first one is, when do you want to use a terrestrial LIDAR scanner project? First, you want to apply the TLS on projects or sites that are, compact and dense. The instrument can be set up in various locations between equipment while maintaining the safe distances as dictated by the station. Some station sites, you're allowed to get a little bit closer to the equipment, but when you ramp up that kilovolts, you're limited on how close you can get to the equipment. With its versatility, you can also utilize it when you may not have access inside the substation. As you can see in the picture, the scanner is placed on a tripod that is raised above the height of the fence and collecting data from the safety of the outside and controlled access. TLS scanning is an appropriate method when higher density or detail is needed. Like it's mentioned, we can get in there with the equipment, keeping close those maximum distances and get good, precise information on that substation equipment. As we stated before, scanning reduces time inside the substation and in some cases eliminates the need to be inside the station. It's cost-effective to use on a variety of substations. Additionally, you can meet multiple scopes when scanning. This TLS scanner is going to be the workhorse for majority of your substation projects. due to the density and need to be around that equipment, but collecting from a safe distance. When it comes to mobile LIDAR, it has its own unique applications for substations. If the substation is large, spacious, and open, you can drive the vehicle around areas and collect survey information, which again greatly reduces the amount of time inside the substation. Then you can supplement any inaccessible areas with your TLS scanner and obtain full coverage of the site. Another thing to consider is if the driveway or access to the substation is part of the scope, the mobile unit can be driven on the access road, collecting that information you need to make those improvements to that substation. Again, the mobile unit is a cost-effective measure for larger areas, larger substation sites. Typically, you use these on sites 9, 10 plus acres. And finally, our last method to collect is a UAV or drone. With the advancement of drones and their capabilities of carrying LIDAR units as payload, the UAV has become an invaluable tool for LIDAR applications. For substations, they are additionally useful if you plan on attaining ortho imagery of the site. Also, if the utility is planning on expanding the station site, the UAV can collect acres to hundreds of acres of data in a matter of minutes, both inside the substation out. Similar to mobile, you can supplement any areas with TLS scanner and get full coverage of the site. It is also useful in additional data is needed for the transmission and distribution lines coming in and leaving the station site. Kevin, do you have anything you'd want to share?
No, I think you've covered it well there. When you talked about the three different methods of gathering the LIDAR, of course, the one thing that ties it all together there is good control or survey control that puts all those methods from the ground, mobile, in the air together with the LIDAR. Very comprehensive method to capture everything.
Thank you, Kevin. So now that you have the LIDAR data, what exactly can you do with it? The benefit of LIDAR is that the data is scalable. And by scalable, that means, you can have your low-end outputs where you might just need basic measurements, very rudimentary type information, to, high-end outputs where, you're developing BIM models, 3D models. So as an added benefit, because the work is being managed by a licensed surveyor, point clouds can be brought to any datum, whether it's plant coordinates, site coordinates, or even published state plane coordinates. Again, some examples of low-end deliverables. Measurements, essentially everything you can see can be measured. Typical details are able to be generated on poles, transformers, conductors, or any piece of equipment inside of that substation. Then with the imagery that is collected, engineers, surveyors can perform analysis and inspections of equipment and visually inspect the integrity of the equipment. Also, there are applications for vegetation management. If vegetation is encroaching on your substation, LIDAR can help document and mitigate that. And again, construction monitoring. If you need to monitor stockpiles or if you want to see progress of the substation, LIDAR is a good application just for monitoring purposes. Now for some higher end outputs, as you can see in the video that's playing, this is a simple 3D model developed from a LIDAR scan. When it comes to models, there are 4 various levels of detail that can be requested. As you can imagine, each level gets a little bit more detailed as you progress up. LIDAR can also be utilized to develop topographic maps showing contours of the station, berms, and other important features that you might need to document and see. Foundation plans, as-built plans are also easily developed. As you can see in the model below, the foundations are easily designated and obtained. Another added benefit is cloud comparison. If there's a reason to believe any equipment is settling, deforming, point clouds can be analyzed, against each other. So essentially you can go out, collect your LIDAR data, have your baseline information, do any weekly, monthly, yearly monitoring, and then you can compare those results, from year to year, whatever that time frame is that you're looking at monitoring. As you heard us mention, scanning can meet multiple scopes in one trip. There was a station site that was scanned with TLS methods, and a transformer blew out and needed a complete replacement. Since the data was what we call in the can, information regarding that foundation, elevation, topographic data was able to be generated and delivered. This allowed the utility to avoid additional survey, which would require, additional oversight, additional mapping, just time that transformer was down and not being productive as part of the substation facility. So what that in turn was, cost savings to the utility, because that substation, we had the data was already collected, the information needed to meet that scope was pulled and got that station back online sooner. The next example of some cost saving and added benefits of a scanned substation is a station was scanned and a construction contractor, he was needing wire height information on the lines around a substation coming in and out, and even some that was outside of the substation. He was concerned about moving in equipment, supplies, and other items necessary for substation improvements. He had a specific height that his vehicle was at, along with like the equipment and supplies on it, but he was unsure if he was going to hit wires or run into anything. So the scan data was able to be referenced, measured, and marked in the field, allowing the contractor to safely mobilize without any interruption to the facility site, or even any delays for him. He was essentially to make his delivery in one shot. So to recap, the most important aspect of LIDAR applications for substations is the safety factor. LIDAR greatly reduces the hazards that the project team is exposed to, and even eliminates some of those hazards. Again, with the hierarchy of controls, elimination is the fail-safe method to keep everybody safe. It is a cost-saving measure by effectively collecting and gathering data on anything and everything that you can see. There is more than one method to collect, which give you options as to what tool you need for the job. And again, LIDAR can meet multiple scopes, all with one trip to the site. So now we'll open up to Maria if there are any questions and answers.
Okay, excuse me. Thank you, Dustin, and thank you, Kevin. We have a few questions here. The first question is from Joe, and he asked, if you are scanning from outside of the fence, how do you prevent missing data?
When we're scanning from the outside, we perform multiple setups to ensure integrity of the data. Also, elevation and height is your friend. So having that equipment where you can mount that tripod, above any fences or any other features that may impede the sight lines. That's, critical to get those scans set up and have multiple scans in your locations.
Okay, thank you. The second question comes from Jen, and her question is, what is the typical deliverables?
Kevin, would you like to answer this?
Sure. So it's actually quite diverse. At the very basic, like Dustin mentioned, where someone's looking for clearances, we can do that right there in the field, processing the data and deliver images, PDFs or JPEGs or TIFFs, or full 3D models with varying levels of detail, or at the very least, when it comes to LIDAR, we can deliver the cloud, or the cloud information can be delivered in a format that suits the requester's CAD package. So it could be the actual IMP file or PTS. There's a number of different formats, but we can deliver the raw scan data as well.
Thank you. One more question. This is from Paul, and his question is, what type of software do you use to process data?
That is a good question. Cyclone is our main software that we utilize for registration of the point clouds. You can also utilize Recap, and Trimble Business Center is how we process all the survey control, so we can tie in everything together. That's how we are able to bring it down to those like plant coordinates, site coordinates, or state plane coordinates. For extraction, again, Cyclone can be utilized for this, but we also rely heavily on TopoDot, which is a built-on platform for MicroStation.
Thank you. Okay, I think this concludes the Q&A session for this presentation. I don't see any other questions coming in through the chat conversation, so I could hand it back over to you, Dustin and Kevin, for any final words or last remarks.
I'm all good at this end, Dustin. How about you?
Yeah, just like to remind everyone to check our website out for more upcoming webinars. You can visit mazerconsulting.com/events for more information. We've been performing these about two per week. There's a lot of good topics coming up, so check the website out for more information.
One other note, Dustin, I believe this webinar here will be coming around again. It's not the last time we'll hear this one either. Is that correct?
Yes, I believe that is correct.
I apologize. We do have one more question, and I think it's a good question here, so I'd like to just pose this for the last one here. And the question is, how accurate is the data?
Kevin, would you like to answer this?
Okay, at its very, very best, with accuracy, the answer always is it depends. At its very, very best, we're used to delivering models that are good to 1/8 of an inch. Thank you.
Thank you again to everybody for joining. If you have any questions, contact Survey Webinars at Mazer Consulting if you would like any more detailed information.